code block. I have these pictures here. After that, what happened? What should I modify in the picture?
Not even A.
Yeah, A is now.
A has the value of C, right? So single quote C. All right. And then this, after that, what happened?
Backdoors the address of A.
Address of A is put in B. So this box has the value of 1024. And the arrow is established. And then this,
2016 to C.
2016 is stored in the box C. Because there's a pointer that points to a pointer. Okay? Therefore now you understand the pointer itself have address. If you want the address of a pointer to be used, you need to declare a double pointer. Okay? So the double pointer is used to store the address of a pointer, and that's it. Okay, and there are some advanced topic like void pointers, and invalid pointers, and null pointers, and pointers to functions. Okay, these are more advanced topics. I will skip here, but you can find out more on your own by reading the textbook and also reading additional references. All right, we have a few minutes that I'd like to briefly introduce the concept of a structure. And chapter 14 is about dynamic memory. It is not very important at this point because it does not, in no way, affect programming itself. However, when you program something large, it is a very important issue. What happens is that when you write a very large program, you declare a lot of variables, you use a lot of memory space. Now, some of those variables, they have local scope. So there's no need for them to exist from the beginning of the program until the end of the program. Okay, maybe just in the middle. In that case, you may want to use dynamic memory allocation. So when it comes, the need comes a lot allocate memory to them. When they are done, eliminate them and reclaim the memory space so it can be used for something else. Okay, so that's what dynamic memory space is about. So once you know this concept, that should be enough. When you program it, you just find out the syntax how to do that. Okay, so it does not affect the functionality of your program actually, but it affects practically how much memory you use when you program something. So it's an important issue later on, but not now. All right, chapter 15 is about data structures. It is also a nice way or a natural way to introduce later a more important concept called class. In a way, a data structure is very similar to a class. Okay, I think the best way to introduce that is use the example. The keyword is struct. Okay, product. Integer, weight, and double, price. Okay, what does that, and then Here. Okay, this is a program declaration statement. What does it do is declare a structure. What is a structure? A structure is, you can say, is a package of numbers. Okay, so it's like a basket. Inside the basket, you can put different things inside. These different things are individual data. Okay, okay. In this statement, one basket or one package called, of the type of a structure type is called product. And this, when you have a product type, it can store two numbers in it. Okay. All right. This is a declaration of the prototype of the product type. Then with that, I can declare product like an apple, Here, this is the structure type. This is called a type. Just like integer type, float type, or double type. And this is the variable name. Okay? So that will declare the name apple as a struct product type. Then I can also declare another one, product. And price. Oh, no, not price. Orange. Okay, then orange is also of a product struct type. Right? Now the question is, how do I access those numbers? Okay? The way to think of a struct data type is that you have a basket and inside you have things. It is those things, the number, individual numbers you want to manipulate, right? Well, the way to access this is, well, apple will have two data inside its basket. You access that by this operator, the dot operator, and then weight. If, say, your apple, you have one apple, its weight is 2 pounds, you can do it like that. It is 2. Okay, and its price is apple dot price equals 0.5. And then my orange weight is, let's say 3. My orange price, let's say, is 80 cents. Okay? Alright, now you can see the thing in front is the label for the struct data type. The thing behind the dot is individual data. That's how you access the individual data defined inside. Okay? Therefore, now you can see I have the price, I have the weight, and then I have price. And this whole thing is a struct. I called it apple. And then here I have orange. Inside it has its own weight and price. Okay, after this initialization, this box has the value of 2. This has the value of 0.5, this has the value of 3 and 0.8. Okay, that's how the data structure is used. Now you can see Actually, struct data type is very, very useful for record keeping. For example, when we talk about student at K-State, it seems very natural for us to define a struct type of called like student. So you can say struct student. All right, what do you think we should put inside the student? Some useful information about the student, right? What about wildcat ID, right? That's of the integer type, WID. You may have some biographical data, like date of birth, right? You may want to have a double type to store is GPA. You may have some others. The height of the student, maybe the weight. Do you enter this? Maybe that's a little bit too intrusive. If that's the case, we don't define that. But definitely address, phone number, things like that. Once you define that, now you can say student, let's say Tom, okay, and you can use you can use full name. Let's just use first name, okay? And then I have student Jane. I have student Charlie, etc. Okay? Oh, no, this Charlie. And many students. Once I do that, for each student, I will be able to enter those individual data. Okay? What this individual data in C language is called a member data or element of a struct, okay, or just member. The textbook tends to use the name member. I think I like to use element or member data that is more indicative. Okay. Now you understand, struct is a way to package a bunch of data together which are relevant, meaningful for that struct, and once you define that, you can declare many instances of the struct, and at that point, it's already close to the concept of class. Class is again a basket. You can define different numbers inside the basket, but there is something additional that struct does not have. For a class, you can also define functions or actions. So that's what we are going to do next class. Okay, that will be it for today.